Okay. Hi, everyone. Welcome to the International Methods Colloquium. I'm Justin Essery, Associate Professor of Politics and International Affairs at Wake Forest University. The International Methods Colloquium is a periodic online interactive seminar discussion on the application of quantitative statistical methodology to the social sciences, sponsored by Wake Forest University and previously sponsored by Rice University and the National Science Foundation. This week's speaker is Pablo Barbera, Assistant Professor at the London School of Economics. He's giving a talk entitled Ideal Point Estimation Using Twitter Data. The talk's going to last about 30 to 40 minutes, after which point we will take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of your webinar window. And I want to say you can ask questions at any time during the talk, and we will get them. But unless it's a clarifying question, I'm going to hold all the questions until the end of the presentation. A link to Pablo's slideshow will be available in the Zoom webinar chat window, so you can refer to it throughout the presentation. And I'll post that link to the right after we get started here. And now I'd like to welcome Pablo Barbera to the IMC. Welcome.
Thank you so much. Thank you so much for inviting me to be part of this, and thank you for this great initiative. It's an honor to be part of this, and thank you to everybody who's watching now or later. So as you mentioned, I'm going to be talking about ideal point estimation using Twitter data, which is something that has occupied my attention quite a lot over the past few years. So a little bit of the motivation for this broader research agenda stems from the fact of understanding how digital technologies is transforming our everyday life. When we think about how we used to consume political information, probably an image like this comes to mind. We used to rely on newspapers and TVs and conversations with our families and friends to learn about what's going on in the world politically. But today, this picture looks a little bit more like this, right? So we increasingly rely on digital technologies on our laptops and our cell phones. We log on Facebook and Twitter every day or every other day to check what's happening. We use messaging apps to communicate with our families and friends. And this is a quite interesting transformation that obviously represents a pretty profound shift in how we communicate, with implications for a wide variety of political outcomes. So thinking about election campaigns, how we interact with politicians and how politicians interact with us, public diplomacy in their interactions between countries, obviously protest, collective action. There's a range of political outcomes that have been affected by digital technologies. And part of my research in the past few years has focused on understanding that transformation. But there's another part of this change that I find particularly interesting, and my talk today will focus on that, which is how we can extract meaningful information from these geolocated, time-stamped digital traces that people leave behind when they use digital technologies. And one of those traces that they leave behind is how they communicate with others, like the networks in which they are embedded. And today, what I want to talk about is how we can use those networks from social media sites to address one of, I think, the standing questions and a pretty interesting question in the study of political methodology, which is ideal point estimation, so measuring political ideology. And what I show today is some of my research developing methods to estimate ideal points for different types of actors on the same latent space and across multiple countries. So I'll talk a little bit about that method and how to validate it. And then I will also go over two extensions or substantive applications that demonstrate the validity and the usefulness of these new metrics. And that will be related to this debate about social media as ideological echo chambers, and the whole idea of to what extent social media might be exacerbating political polarization. So I'll show that even if most individuals are indeed embedded in homophilic networks where all the content that they interact with aligns with their political beliefs, there's still a pretty significant degree of exposure to diverse ideas, or definitely much higher than what is commonly assumed. So let's dig into it. So ideal point estimation. So we know that we need those ideal points. We need those estimates of political ideology for a wide range of questions of substantive interest in political science and the social sciences more generally, right? So if we want to understand the behavior of politicians or political parties, of voters or justices, or countries and governments, there's a wide range of applications in which these ideal points have become particularly helpful to answer some of these important questions. And this goes beyond political science and IR, right? If we look at the literature on political communication, we know that political ideology plays a very important role in, for example, how individuals decide to consume political news. In the study of social networks, again, like we know, ideological or political homophily is a very important force explaining how we decide to interact with others. And same in political psychology, we know that ideology is correlated with a range of important psychological traits that define who we are and affect our behavior. And not surprisingly, given how widespread the use of these ideal points has been in the literature, there's also been a wide range of efforts to try to measure them, right? So in political science, some of the gold standard metrics of political ideology in Congress have relied on roll call votes in legislatures, both in the US and in other countries as well. We have used similar types of data to measure the ideology, for example, of Supreme Court justices, looking at how they decide on particular cases. Other types of approaches have relied on expert surveys, on text analysis of party manifestos or speeches or press releases. There's been efforts to also look at survey responses of where people perceive politicians to be, or trying to combine survey responses of politicians and citizens to try to scale them on the same latent dimension. There's behavioral metrics like the work by Adam Bonica looking at campaign contributions. And finally, there's also a lot of effort to combine different types of sources to see if we can get the best of both worlds, right? Like thinking about combining speeches in parliament with also, how specific politicians are voting on relevant bills in Congress. But there's also some well-known limitations in this literature, right? So a lot of this work is limited to specific populations. So for example, roll call votes, we know we can only apply them to legislators, right? So we cannot compare legislators and citizens on the same scale, at least not directly, because we don't have citizens voting on specific bills. There's also issues when we want to compare, for example, across countries, right? So even if we had, roll call votes in legislators, the bills would be different across different countries. So there's the question of how do you bridge these, ideal points that come from like different countries. And finally, even if we could, run an expert survey on, every politician in the world, that would be quite expensive, right? So there's this cost of either asking experts to rate the ideology of politicians, or if we want to do human coding of text, that can be quite expensive. So my research on this area, what I've tried to do is okay, can we add one more bullet point to this slide? Can we use social media data as a new source of data to overcome some of the limitations or the previous approaches to complement and try to go beyond what other researchers have done in this field? And, there's a question mark, can we do it? I think we can. And part of my work, again, has focused on that. And this is one graph that I think illustrates the potential of these metrics. So this is from a blog post that I wrote for the monkey cage before the 2016 election, where I tried to look at, who is the most conservative candidate that was running for president at the time, right? And here I plot, again, this I think illustrates the strength of this method. So each of these ideal points here corresponds to one politician running in the election in the Republican primary in red, the Democratic primary in blue. But then we can also add to this plot anybody that has a media account, a Twitter account, and that includes the accounts of media outlets, right? So we can make meaningful comparisons on the ideology of Fox News with respect to prominent Republican politicians running for president. We can also add Democrats and Republicans in Congress, which are represented here as with this red and blue density. So you could make comparisons about, Jeb Bush is to the left of the median Republican in Congress, or Senator Sanders is around the 30th percentile of the ideology distribution in Congress. And you can also place ordinary people, any type of Twitter user on this scale. And that's what this gray density plot represents. And this shows us one of the classic results in the literature and ideology in Congress and the public in American politics that shows this bimodal distribution of politicians in Congress and a more kind of normal distribution for the sample of ordinary citizens, right? So again, I think this illustrates this strength of comparing multiple types of people on the same latent scale, adding citizens to the mix, etc. So now, let's take one step back and like try to see how do we get here? Like, what is the method to estimate these ideal points, right? And it relies on a model that is very similar to other models that kind of like are in the background on how we estimate ideology, for example, based on roll call votes, which is this idea of like spatial models of politics. No? So all actors are assumed to have some unobserved latent scale on some possibly multidimensional space. And then what we do observe is some kind of behavior. And we use that behavior that votes in Congress on relevant political bills, or words if we're looking at speeches, or the money that individuals contribute to political campaigns, to kind of like try to reverse engineer these positions on the latent scale, right? And the idea is that this behavior is somewhat costly, and it tells us something about their latent ideological positions, because this behavior will be a function of the ideological distance on that latent scale. So, for example, the Adam Bonica model of campaign contributions, donors give money to candidates that they perceive to be good representatives of their own policy positions. Okay, so how do we go from this, classic models of a spatial model of politics to Twitter? So what I claim was like, oh, we can build like spatial following models. So the idea here is that this observed behavior is going to be the decisions by Twitter users to follow political accounts that they perceive to be ideologically close to their own opinions, right? So political accounts here will be, politicians in Congress, candidates running in an election, political parties, but here include also, for example, media outlets that are partisan or that, write about politics on Twitter. And again, the idea is that Twitter users are going to be connected to, they're going to decide to follow those accounts that they perceive to be producing information that is close to where they stand on this latent political dimension. And why would we expect that to happen? Well, because when you decide to follow someone on Twitter, you're exposed to everything that they're posting online. So this is a signal about how you decide to allocate a scarce resource, which is your attention, right? So in the same way as in the scaling campaign contributions is a signal of the allocation of scarce resource, which is money. Well, here it's attention, because most people don't have the attention span to follow everybody on Twitter. You have to be somewhat selective. And sure, like some people may not be selective, but as long as most people are selective, we will have a model that works. And again, this is also related to this literature on political communication about how we self-select ourselves into media outlets that are producing political content or like news content that is congenial with our own political attitudes, and we want to avoid anything that may challenge our own opinions. So once we have this assumption, we can build a model that will allow us to estimate, this like in an unsupervised way, the ideal points for both individuals who choose to follow political accounts and those political accounts. And this is very similar to, for example, in the network science literature, people like scaling networks through like latent space models. Okay, so I'll give you a sense of how this works first with an example, and then I'll get into the math a little bit, right? So let's assume we have this Twitter user, and his name is Ryan Pitrick, and this is his network on Twitter, right? So each of the dots here is going to be one account that he follows on Twitter. The edges or connections indicate whether those accounts follow one another in turn. Well, from his network on Twitter, we're going to subset only the political accounts represented here as a slightly bigger nodes. And in this case, which again is, not real data, but, it could be real data. He follows Senator Rob Portman from Ohio. He follows Barack Obama on Twitter. He follows Paul Krugman, Rachel Maddow, right? So a range of, kind of like left-leaning political accounts, right? So this already gives you a clue of where this individual is going to fall on this latent ideological dimension. Well, from this network, we're going to build a vector of zeros and ones, where here we have a list of M political accounts that we choose, somewhat arbitrarily, but the idea is to get something like 600, 700 accounts that we think that following them is relatively informative about political ideology. So this person follows the White House and Barack Obama, but not the GOP. And this is just one user, but we could build this type of vector for possibly everybody on Twitter. And we may end up with a matrix like this, which looks very similar to a matrix of roll call votes of legislators voting for bills in Congress, but also an adjacency metric. So we were like doing this from a kind of like network science perspective. And we know there are very good scaling methods, so we can apply one of those to these metrics to estimate the ideal point for this particular user. We're gonna represent that as theta I, and that's -1. And that's particularly convenient because by construction, this dimension of ideology is going to have mean 0 standard deviation 1. So from that, we could derive that this individual is 1 standard deviation to the left of the average person on Twitter in the US. And by the way, I've not shown here, but this also gives us estimates of the ideal points of the political account, right? So all of these political accounts would be estimated to be on the left, with the exception of Rob Portman, who is a Republican senator. Okay, so let me explain a bit more about how we got from these metrics to this ideal point, right? So we defined users and political accounts ideology, theta I and phi j, as latent variables that we're going to be estimating with a model. And this will be a completely unsupervised model, right? So the only data that we have is that matrix that I was just showing you that indicates how users on Twitter choose to follow or not a set of political accounts. And then we build this model where we're going to try to kind of like model the probability that each user I follows political account J, right? So again, this would be quite similar to the probability of a legislator I voting yay on a bill J, right? But it's slightly different, and I'll try to walk you through why that's different, right? The idea here is like this probability is going to be, so probability of observing that link occurring is going to be a function of these terms here, and these terms are, and again, everything here will be latent. So these terms are theta I. We already know that's the ideology of user I on this latent dimension. Then we have phi j, which will be the ideology of the political account J. And we also had some random terms, one for what I call the popularity of political account J, right? So some political accounts, simply because they're more important in Congress, for example, they're just going to have more followers, and that's not necessarily informative about their ideology, right? So just like we add this term to account for the fact that, for some accounts J, this probability is just going to be higher. And we have something similar for users, right? So political interest for some users will be higher simply because they just want to follow more politicians. But the magic, let's say, in this model happens here, right? In this term of the equation. The idea is the farther you are, the farther the user is from the political account, the less likely it is that that user will follow that political account, right? And this gamma term here is a normalizing constant that will give us the importance of political ideology, right? So the model is, general, in a way, like the model could tell us that ideology is not important, right? This like gamma term could be 0. It will not be 0, it will be positive. So this becomes negative because ideology does matter in how we choose to follow or not these political accounts. But again, it regulates that relative importance of ideology, right? So the goal is going to be estimating all these terms here, which are all latent, just looking at that matrix of following decisions. And this is the likelihood function that we had to minimize to find those parameters. Turns out that this is kind of a complex problem computationally, because we quite literally have millions of parameters to estimate, and this is intractable with like standard maximum likelihood methods. So one solution to this would be, okay, let's just use Markov chain Monte Carlo, and let's just try to do this. It's still a lot of parameters, but something that I toyed with and just published in a political analysis piece where I introduced this model is that, well, maybe we can split this estimation into 2 parts. One with a small subset of the entire matrix of users following politicians, where we run like MCMC on just with this matrix to estimate the parameters that are indexed by J, which are fewer, and we assume them to be relatively stable once we estimate them with some accuracy. And then once we have those J index parameters, we can just do like Metropolis Hastings algorithms. We can just parallelize it. That's very easy to do to estimate the ideology of all the I index parameters, which are the ones that represent the users here, right? And then we just need to make some identifying assumptions. One I already explained, which is the unit variance restriction on theta, which is also quite convenient for us because it makes it easier to compare the estimates that we get. We also need to fix some hyperparameters on some of these like random terms to make sure the model is identified, right? So this is anyway. So this is one way in which we could fit the model, which I think is computationally is kind of interesting to think about. In this world of big data, how do we fit these models where we have billions of parameters? But it might not be the best way. So in a recent article by Kosuke Imai and co-authors published in APSR, an excellent article where they apply these like ideal point estimation models to big data, they find a much better way of doing things, which is through variational inference, and in particular with an expectation maximization algorithm. So in the paper, I read with a lot of interest that they actually were able to replicate some of my initial work, which is very exciting and reassuring. But also they were able to reduce the running time quite significantly. So initially, the model, when I ran this in the paper published in Political Analysis, it took me something like 5 to 7 days to fit the model. They were able to, through this like EM algorithm, they were able to reduce the time that it takes to run this to only 35 minutes. But then after that, I've been thinking a lot about, are there other ways that we could fit this model that might be better? And I've been experimenting with a type of like matrix factorization method, which is correspondence analysis, which is similar to what Adam Bonica has been using in some of his recent work, which consists in basically standardizing first like these like metrics that I was showing you, so that we like reduce the impact of these like random terms for the users and for the politicians, and then we just use the so-called Swiss Army knife of big data, which is the singular value decomposition. So we do it to that matrix, and we get the left and the right vectors. We project them back into the same space, and it turns out this actually is quite similar mathematically to that initial model that I presented, and it's much more computationally efficient. And actually, right now we don't have a need for like this like two-stage model. We could just like fit the model with like the entire metrics, which as I will explain in a moment, can be something like 15, 20 million rows, and then 600 columns. So I replicated the replication by Kosuke Imai and others, and something that took them 35 minutes to run with this correspondence analysis method. It takes only 1.88 seconds. So from the initial run of my model, from 6.5 days to 1.88 seconds, I would call that a success. So that's a little bit of the method. And now what I want to do in the remainder of the talk is talk to you a little bit about how I've gone about validating and making sure that the results that I'm getting out of this model are actually something meaningful that we can use in different ways, right? So, and then I'll talk a little bit about that application that I mentioned in the beginning. So the way I'm going to validate this is I'm going to show you results from a run of the model, where I took a list of nearly 600 popular political accounts in the US. Then I downloaded the list of anybody that follows at least 5 of these accounts, and this turns out to be 12.6 million users. So we're going to estimate 12.6 million ideal points, and this is roughly 30% of all Twitter users in the US. Which not everybody, and this is going to be a source of sampling bias. The results I'll show you here are mostly from November 2016, but I have like more recent results. And if you want to learn more about all the work that I've done on this, and if you want to play around with the code, you can go to tweetscores.com, and you can also check an R package that you will find on that website that contains code to interact with the Twitter API, run this model. And if you don't want to run the full model, you can also just like run it for a specific Twitter user. So all the code is there, and you can, again, estimate the ideology for any Twitter user using this R package. So I'll skip this, and I just want to show you just like how to validate some of these metrics, right? Because I've been thinking a lot about this, and I think this, we can look at, the two sets of ideal point estimates that we have, and see how to, we can validate those. So we can look at political elites first, these political accounts, and second, we can also look at ordinary citizens. And for political elites, I guess like the gold standard, what everybody does every time you run, a new ideal point estimation method with US politicians is, okay, let's compare it to DW Nominate, or let's compare it to the Clinton et al. Ideal point scores. And this is what that graph looks like with the most recent run of the model, the correlation between the ideal points from Twitter here on the x-axis, and the estimates from the Clinton et al. Method using also MCMC applied to the matrix of roll call votes is 0.93. which sounds high, and you can see there's a linear relationship between these two things. But let's not forget that just having a dummy variable for political party already gives you a 0.94 correlation with these ideal points, right? So what we need to look at is actually the intra-party correlations, which don't look as impressive, and they're definitely below 0.9, right? So for Republicans is 0.45, for Democrats is 0.63. So something that's very useful is a paper that Chris Dosanovich and Chris Warshaw published last year in Political Analysis, where they did a pretty useful systematic comparisons of how different estimates of political ideology in the US Congress compare against one another and against metrics based on roll call votes. And you can see here that methods based on expert surveys and citizen surveys and the campaign contributions, actually the inter-party correlations are kind of similar to what I found with Twitter data in the original Political Analysis paper. With some of the recent runs of the model, actually, these correlations become much larger. That's because now I'm able to run the model with like the full matrix, which gives me like much more accurate results. So you can see here that these estimates based on Twitter data, despite being completely unsupervised and in some ways removed from all type of actual votes, outperform some of these other metrics that are asked people more like they're like in a way much more related to politics than the Twitter stuff that I do. We can also look at citizens to do another type of validation, which is looking at whether the ideology estimates for citizens are actually good, that we get from Twitter. They're actually correlated with what we would find based on surveys, for example. And in this slide here, that's what I do. But here I aggregate different geographic units. So here, this graph on the right, on the left is at the state level, and you can see here on the x-axis the average ideal point for each state. On the y-axis, a metric of liberalism at the state level based on an MRP model. Here on the right, you find something similar, but for the top 1,000 cities in the US, again, comparing it to survey-based estimates of ideology. And in both cases, you can see that there's a pretty high correlation between, again, metrics that come from Twitter networks with those based on survey data, despite all potential concerns about the representativeness of Twitter samples, et cetera. So despite that, you can see there's a pretty high correlation. And the other type of validation, which is perhaps, in a way, like hopefully the most convincing, is validation at the individual level for citizens, right? And some of the work that we've been doing in terms of data collection in the past few years has consisted on trying to match Twitter accounts with voting registration records in some states in the US where they are publicly available and they can be used for research, right? So the way we do this is that we take geolocated tweets that come from specific areas of a given state, and then we try to find if there's like someone with the same name in the same geographic area, and then if there's a match, then we say, okay, this Twitter account is this voter. And in the voter file, we have party affiliation, right? Because in many states, that has to be public because that is used to then look at who can vote in the primary election. So this is a sample of 5 states where we have that type of data. And you can see that in all of these 5 states, we do see a pretty high correspondence between the party registration of the Twitter users, like the voters that we look at, and then the Twitter-based ideology estimates, right? So again, not surprisingly, we find that most Democrats in each of these states have an ideal point estimate that is to the left of 0, which by construction will be the average. And for Republicans, most of them are to the right of 0. And sure, there's a lot of kind of like errors in both directions. But still, if we take that 0 as a threshold to predict whether someone is a Democrat or a Republican, we get a predicted accuracy of 83%. And that probably would be higher if it were not because we have in California a lot of Republicans that, in comparison with other states, they're actually quite left-leaning in our sample. I'm happy to explain more about the data in the Q&A. I have some more slides here. So that's kind of validation, and hopefully I've convinced you that we get pretty good and pretty accurate ideal point estimates for both politicians and also for citizens. So now what I want to talk about in the remaining few minutes is some extensions of this model that I'm currently working on, still unpublished, but still like, thinking about this and like thinking, how to solve some of these problems. And I'll talk about how to expand this to multiple dimensions, which makes a lot of sense in the European context, for example, where you have many parties and multiple dimensions of political competition. And then I'll talk a little bit about social media's echo chambers, right? So starting with this idea of multidimensional policy spaces. So in the paper that I published in Political Analysis, I already had some examples of running this method in other countries. So for example, in Germany, this is data from 2013, these estimates of ideology represented here on the left for politicians of each of the 6 major parties in Germany at the time are quite highly correlated with where these different parties stand on this left-right dimension according to expert surveys, right? So there might be some minor errors, but generally, all the politicians are clustered around the median of the party, and they're all correctly classified as being on the left or on the right. But when we got to the UK, what I found was that actually the first dimension of that, the dimension that was discovering through this method with the Twitter data was basically capturing government versus opposition dynamics, right? So you can see here, so at the time, remember that there was a coalition government between Lib Dems and Conservatives. And you can see here that sure, Labour is on the left on this dimension, but then Lib Dems and Conservatives, the positions are quite, like they overlap a lot, even if we know that Lib Dems are probably closer to Labour on this like left-right dimension, which is what you find when you look at expert surveys, right? And in a way, that's not surprising because this method is just going to capture the first dimension, whatever, like the first dimension, whatever, whatever explains most variance on these following decisions. And at the time, it seems that this like government versus opposition dynamics were what mattered more than just like left-right ideology, which again makes sense because of this like coalition government situation. So what I wonder is like, okay, can we generalize the model to multiple dimensions, right? So let's go back to this equation that I showed you earlier, that where we have all these like unsupervised, this like kind of like unobserved parameters that we try to estimate. And what we can do is we can just take this equation and we can make it multidimensional, right? So instead of having one gamma parameter, we can have capital D gamma parameters, and also we can have estimates of ideology on multiple dimensions, right? On any like D dimension. Fitting the model is the part that will be tricky because we need to add more like identifying assumptions. But again, one of the advantages of using correspondence analysis, this type of like matrix factorization method, is that it already like incorporates like these multiple dimensions. So in a way, it's it's easy, computationally efficient to derive these estimates on the multiple dimensions. There's like some complications that I'd be happy to discuss as well, but as I'll show you in a moment, we get like pretty good results. And then we can apply bridging methods, like same as like James Law and co-authors, for example, have used to compare estimates of ideal points in the European Parliament across multiple countries. In this case, we can use survey responses of individuals on the left-right dimension across multiple countries to serve as bridges, right? So we can look at the positions of these of politicians on this dimension of like where citizens perceive them to be, and then just use as a bridging device to try to get estimates that can be comparable across different countries in Europe. And these are some of the preliminary results. This is joint work with Sebastian Popa and Hermann Schmidt, and still like work in progress. But we get some like pretty promising results. And here I show you results for 2 dimensions that we identify in the data. Not necessarily the first and second dimension. Each country is different. Well, we can see pretty clearly in every country. Here we looked at all 28 European countries for now. We'll see what happens after Brexit. But we see here that we get pretty high correlation between the ideology estimates that we would find from survey results on like where citizens perceive parties to be on the left-right dimension with our estimates of ideology based on Twitter. And the same with where citizens perceive these politicians to be on the anti-pro-European dimension, again, compared to estimates from Twitter. And again, this may not be the first and the second dimension in each country, but we basically went dimension by dimension to try to see which one was like EU versus anti-EU, and which one was like left versus right. And you can see that, within countries, we again like find results that now are like consistent with our expectations. Like this is Germany, and we find a pretty much higher correlation than in some of my earlier work. Also, again, looking at the European dimension, also this is the UK, for example. You find like the UK, which is like this like Eurosceptic party, which is like much more anti-EU than pretty much every other country, every other party in the UK. So, and then just to conclude briefly, I want to show you like one of the applications of this method, right? Which is the idea of like looking at to what extent we are embedded in ideologically homogeneous networks on social media, which is something that now we can estimate through this, right? And this has received a lot of attention in the academic literature in political science, political communication, sociology recently, right? There's this concern about the extent to which social networking sites are creating, incentivizing communities of like-minded individuals where we are only exposed to information that reinforces our existing views. And this could be reinforced by, ranking algorithms that try to predict what we like, and they give us more of what we like. And kind of like the final concern with all of this is that this could be generating cyber balkanization that could lead to, offline political polarization as well. And there's in fact some work that theorizes that perhaps some of the increase in political polarization that we have experienced in the last 3-5 years could be due to digital technologies more generally, and perhaps social media more in particular. So some of the work we've been doing, and this is joint work with some of my colleagues, former colleagues at NYU, Josh Tucker, John Jost, Jonathan Nagler, and Richard Bonneau. And this is from a paper that we published in Psychological Science a couple of years ago. We tried to analyze the structural information diffusion on social media. We produced network graphs like this, where we look at retweets, right? So each of the edges or like links that you see here is one retweet, and then we each of the nodes is one Twitter account, and then basically try to understand to what extent we find kind of like segregation in how information spreads in the network. And contrary to some of the prior work, which I was showing you here, that exhibits very high levels of ideological segregation, once you use a better method to measure ideology that can produce these ideal point estimates for a larger set of people, we don't find that much segregation after all, right? So this is 2012 election, arguably, probably like where we would expect to find higher levels of segregation. And sure, even if we do see some clustering of like, liberals retweeting other liberals, conservatives retweeting other conservatives, we still find like pretty large flows of information that go from, this cluster to the other cluster. And when we look at topics that are not political at all, like discussions about sports events, we don't find any segregation at all, right? And you may be thinking, well, why would you expect to find political segregation when it comes to sports event? Well, if you take this argument to its, like the corollary of this like argument about cyber balkanization is that it should affect all facets of our lives, and not only when we talk about politics. And you can read more. So in the paper, we do like some other type of like graphical visualization of these networks to try to compare across different types of political discussions. But again, I refer you to the paper if you're interested on that. So I had some more materials, which I'm going to skip in the interest of time. But if you have more questions about this, I'm happy to come back to it. Just to wrap up, again, like what I think is like the contribution of this work is this method to estimate ideal points for a broader set of, politicians and people than other methods before. And hopefully we can also run this on multiple dimensions in multiple countries. But I'm also very well aware of some of the limitations, and I look forward to your thoughts and questions on some of this. So for example, I think the method shows that we get pretty good estimates for elites, not necessarily as good for citizens. There were a lot of errors. There's like obvious sampling bias issue, because we can only do this for people that follow political accounts on Twitter, which we know is not necessarily the average person in the US. And there's a lot of room for improvement, right? So we could combine this with text, for example, which is something that I haven't really explored yet, but I know some other people are also actively working on this problem. So before I conclude, I want to say thank you to some of my co-authors and collaborators on several of these projects. Some of the work that I was presenting relied on work that was joined with especially my colleagues at NYU. And that's all I have. Thank you so much for your attention, and I look forward to any questions, comments that you may have.
Thank you very much, Pablo. At this point, Pablo is available to take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of your webinar window. And we have a couple of questions already, but I want to ask one first. So it seems like the real core of your method is homophily, right? So the way it works is people vote in a sense for certain accounts by following them. And what I'm interested in is that does make sense, right? At a certain level, I don't follow people I find annoying. I do follow people I like to hear from. But I'm also wondering that I know some people have argued that that's not just something that happens in social networks. That's actually something that social networks cause, if that makes sense. Like social media causes people to want to separate. Whereas, I might not move neighborhoods if my neighbor's annoying. But on Twitter, it's really easy for me to just cut him out. And I'm wondering if that the amplifying effect of self-segregation or self-selection in social networks has any implications for the estimates of ideology that you derive.
Yeah, so that's a very good point. I think I agree that's at the core of the method. So I want to explain a little bit more. I mean, the way I think about this is there's two separate sides of this. So one is following political accounts, right? Which is more about which news outlets you consume offline as well. And second is how do you the structure of your network, looking at everybody else, your social ties, right? So in terms of the first part of how you decide which political accounts you follow, and I think I want to show you just one quick slide on this, because I mean we can see for example, using this data combined with the voter files, we can see how people that register as Republican or Democrat, what proportion of them follow political accounts that I included in the model, right? So for example, Hillary Clinton, right? So there's Democrats are something 5 times more likely to follow her than Republicans. Right. This is data from perhaps a couple of years ago, so maybe now this is, the difference is even larger. So sure, there's gonna be, errors in the model and a lot of people that, choose to follow political accounts of the opposite sign. But for the model to work, we only need some propensity towards this self-selection into consumption of information that aligns with your beliefs. Donald Trump is an interesting exception to that. And this is one of the issues that I have with the model, that whenever you follow a political elite that for reasons that are not ideological, you may follow Donald Trump for, other reasons, you want to see what he's putting on Twitter, that may affect the estimate. And this is one of the reasons why Donald Trump, every time I run the model, his ideal point is actually quite close to the center, to the right of the center, but more centers than many people would expect. And it's because of that, right? But then, so that's one part. The second part is this influence of social media to increase our segregation. And I think that's not necessarily the case. Again, I could, I've written papers on this and I've thought a lot about this, but just I think that the summary of that is, I think social media, what they change is that suddenly you can see all this information from your social ties, all the political information that they are sharing. You learn a lot about them politically, and sure, you may tune out and you may, unfollow or unfriend them. But there are so many people in our networks that it's almost impossible to completely tune out. And I think if you think about the counterfactual of your network in an online setting and your network in an offline setting, there's always going to be more diversity in your online network because suddenly you see all this political information from people that you would never interact with offline. You would never discuss politics with them offline. So contrary to this idea of, echo chamber and stuff like that, I think actually social media might be increasing the range of views to which we are exposed to.
Yeah. It's interesting. I don't want to take too much more time with my question. I do kind of wonder, I know that some of these social media companies are trying to manage what you see. They don't just show you whatever someone posts. They try to promote certain things or lower certain things. And that might also have an effect because if Facebook, for example, realizes I don't like to see my dad's political posts, then it might hide them from me, which makes me more likely to stay linked with him. Which, you know what I'm saying? It just gets kind of interesting. I'm gonna go to some of the audience's questions because I'm just indulging my own curiosity. So Robert Kubinek asks, he has two questions. First, can you get standard errors and confidence intervals with the correspondence analysis?
No, you could do some kind of like bootstrapping method or something like that. But no, I know there are ways of computing standard errors with correspondence analysis, which is basically a sophisticated way of doing bootstrapping. But it's quite complicated. It doesn't scale well to this like size of metrics. So no, but you know, who cares about standard errors in the age of big data?
Oh boy, that quote's going to come back to you in a review someday. Another question from Robert is, can we understand the correspondence singular value decomposition in terms of the ideal point social choice model as Clinton, Jackman, and Rivers do with IRT in their 2004 paper?
Yes, I think so. Yeah. I mean, I don't know. I would need to think more about this, but yeah, maybe I misunderstood the question.
Okay. An anonymous attendee asks, how sensitive is your method to different techniques for selecting political entities, and what are the best strategies you found for doing that?
Yeah, so that's a very good question, because my choice at the end of the day is quite arbitrary. I try to be systematic. So for example, I looked at, the Pew Research Center has this list of media outlets that they use whenever they want to compute like media trust, for example, and I just like took that list. I got like, you know, everybody in Congress and stuff like that. But I've experimented a lot with that, and it doesn't seem the results change that much. I think like having like U.S. Congress and, you know, candidates running in the last election, for example, like that's basically all you need to anchor the space.
There's an interesting question from, I hope I'm pronouncing this right, Kakya Chatsu. I want to inquire about the dimension of time. Is the model able to map changes in ideological distance over time? For example, a Twitter user could start following the accounts of politicians and users of a specific ideology, but then might change their preferences and start following politicians of other ideologies. Is that something that can be modeled?
Yes. So I'm actually, that's one of the future extensions that I'm working on right now. Not looking at the changes in users' political, like ideal points, but looking at politicians, right? Because you can take multiple snapshots of the network, literally one every day almost. And so you could compute like ideal points every day. And it's actually, I mean, comparing that with like, you know, the dynamic ideal point model applied to Supreme Court justices, here it's much simpler, because there you have the problem that they're not voting on the same thing every day, right? You just have like the different cases. Here, everybody votes on everything every day by deciding whether they continue following someone or not. So you can have like all this, like, you know, basically you can have like an ideal point for every day. The question is like how much change there is. And actually, I mean, I can show you some of the stuff that we've looked at. This is like Trump and Clinton during the 2016 election. And there is some change, but it's not like that large. And for users, when I looked at this, it's not like that much either, but it can be done. Yes. I think that's an interesting question to explore as well.
You know, one thing that strikes me about Twitter is people do a lot of different things on there. So there's political discussion. There's a lot of discussion of news, some of it political, some of it not. There's sort of friends that are keeping in touch with each other. There's professional people who are sharing things like political scientists or sharing articles, sharing research ideas. There's people doing cat videos and, Nicki Minaj's latest jam or whatever, sharing all kinds of stuff. And I kind of wonder if I noticed your distribution of ordinary Twitter users was sort of single peaked and centered on zero. Is that because a lot of people just aren't following anyone who's political on Twitter? They're not using Twitter for politics stuff, or is that because they're genuinely sort of taking a balanced view from both sides?
That's a good question. I'm not sure. So everybody that is in there has to follow at least 5 political accounts, which is why So in a way like that, get rid of the problem of people not interested in politics, because it's always going to be people that have some mild interest in politics. I think the reason why it's like so much weight in the center is that a lot of the media outlets are in the center, and like
Mhm.
the media outlets like, you know, CNN, New York Times, Wall Street Journal are like quite in the center. So that brings everybody back to the center. Yeah.
Hmm.
And like the most extreme people don't have as many followers compared to those like centrist media outlets.
That's interesting. So what that means is that your measures are really for a subset of the population that are kind of interested in politics. So there's going to
Yes.
be another
Yes.
big lump of people we just don't know anything about.
Yeah. Again, I mean, the way I think about this is like, would those people answer a question about, you know, self-reported ideology on the left-right scale?
Mm-hmm.
Maybe most of them would not. Or even if we ask them, like, it might not be a meaningful response.
Mm-hmm.
So, but I mean, I do agree, like, this is one of the issues, like, you know, if we want to apply this method to, and we want to make like generalizable claims about something that's happening on social media, it's restricted to people that are politically interested. So we need to be aware of that.
Mm-hmm. Anonymous attendee asks, is it possible to measure echo chambers when the ideal points are endogenous to the original estimation strategy? This is sort of getting at the question I asked at the beginning.
Yeah. So yes, I'm going to claim that yes, and I'll show you a little bit why, since I skipped this a little bit. So the way I measure echo chambers, again, I didn't have a lot of time. I'll try to do it briefly. So we use the political accounts to estimate ideology, but then when we measure echo chambers, we exclude those political accounts and we look at everybody else. And my claim is that if you look, you know, get rid of political accounts and actually, you know, get rid of verified users, which are likely to be, you know, celebrities, journalists, and stuff, you end up with people that a Twitter user is likely to know in real life. So in a way, that's less endogenous to, you know, the estimation method. But I agree there's like some certain circularity that goes in both directions, right? So people that are embedded in like homogeneous social networks, that may bias their estimate in, you know, towards like one of the extremes. But I think these two things can be separate. And again, the last thing I will say is that if anything, this would go in favor of the idea of echo chamber and the fact that we don't find echo chambers as much, despite this like bias, this like endogeneity that would like drive up extremism and, you know, homophily on social networks. The fact that despite these forces, we still find, you know, that people are exposed to a range of views and that information spreads across the entire network. I think that, to me, that's strong evidence that we shouldn't be as concerned about echo chambers. There's other ways in which we should be concerned about social networking sites and their impact on democracy and polarization, but not because they limit the range of views to which we are exposed.
There's no more questions from the audience right now, so I want to ask one last question of my own. So obviously, there's a lot of data on Twitter, right? Who you follow. You can also likes, right? You can click the heart button, I think, to like something. You can retweet something. But then there's also what you actually say, right? And your analysis is just using the follow data. And I wonder, that leaves a lot on the table, right? Like these the likes and the retweets and the actual text information on the table. And I wonder if you are working on projects to make use of that other wealth of information that's contained in Twitter and how that might help your estimates.
Yeah, so the funny thing is, like, when I started working on this idea of ideology estimation, I actually started with text. So I was looking at the text of the tweets and I was using this, like, you know, word scores methods and stuff like that to do the ideal points. But I wasn't getting very, very good results. And I thought, like, maybe I should look at the networks. Like, the networks turns out like are much more predictive. And the reason for that is that even if we think a lot of people don't follow politicians, it's like the proportion of people that tweet anything about politics is even lower. So in a way, we get like a much, like, it's like there's like more noise than signal compared like when we look at networks. But there's some people, and like I was excited to see this, that someone was like trying to replicate this model looking at other types of edges within this network. So you mentioned retweets, right? So you can also look at the retweet network. You can look at the mention network. So this is from like kind of like a computer science paper from a conference that like I ran into it and I was like, oh, this is the paper that at some point I wanted to write. So great that someone else did it and I don't have to, or maybe not, I don't know. But the good thing is that they found that like actually like the following like following networks actually contain more information than like mentions and retweets, and part of that is just like they're like less sparse than mentions and retweets, and they have like a bunch of other models that they experimented with. It's kind of like an interesting paper also from the perspective of ideal point estimation models as well.
Mm-hmm. All right, well, we're out of questions, and we're almost out of time. So I think I'm going to go ahead and thank Pablo for being our presenter this week. I want to mention that his presentation will be posted to our website shortly after this broadcast if you'd like to share this presentation with someone else or watch it again later. I also want to mention that on December 7th, we're going to host a talk from Kevin Munger of Princeton University and Penn State. This is rescheduled from before Thanksgiving. The talk is entitled Insufficient Variation in Treatment Moderators, the Limitations of Mechanical Turk for Studying Digital Media Effects. Please check out our website, www.methods-colloquium.com, to get some more information about this talk. Pablo, thanks very much for a very interesting talk today.
Thanks to you. Thanks.
All right. See you next time.